Hi everyone. Okay, so this is your experiment number 7. I'm going to tell you about the steps how you will calculate the inductor current, inductor ripple voltage, and output voltage ripples and input. Okay, so first of all, you have to build this circuit. So how you get these elements? You will go here. You will go to all groups and you will write this number IRF250, and this is the MOSFET you will use. Then for this step you will go to signal voltage sources and then you will go to clock voltage. Okay, so input, you know how to bring it. You will use it 5 volt, and for this you will set 1 kilohertz frequency and 50% duty cycle. Then from here you will bring voltage probe and double click and rename is as V input so that you can differentiate in the simulation. Then this is IL, you have to bring current probe. This is A for current, ampere, and then this is V output. You have to name it V output. Okay, then you have to go to simulate and analysis and simulation. And first I will perform the interactive simulation. When I will run it, I will see that the input is 5 volt and the output is 2.35, which is exactly correct. I should get 2.5 volt because the duty cycle equals to 50%. So this is exactly correct. And then the DC current is 23.5 milliampere. Okay, then you will use this formula. Okay, so duty cycle equals to V output divided by V input. So this output is 2.35 divided by input is 5 volt. So you will get 0.4 duty cycle. Okay. Okay, then this one IL equals to V output divided by R. So duty cycle equals to 0.5. Then Vs is 5 divided by R is how much? 100 ohms. This one. 100 ohms, and then you will get how much answer? Almost 0. I can do it. 0.5 multiplied by 5 divided by 100. 0.025. 025. If I shift the decimal, it will be 25 milliampere, which is exactly the same here. Okay, so this way you should match your answers with the simulation. Then how we can calculate the ripple current and the ripple voltage. Delta IL, inductor ripple current, and delta VC is the output voltage ripple or the capacitor voltage ripple. Okay, you will go to your simulation. You will go to simulate, analysis and okay, stop, simulate, analysis and simulation, and then you will go to transient. Okay, you have to select the stop time 1, then save, and then run. Okay, so this is your output. Now this is V input, this is V output, and this is IL, means inductor current. I'm not interested in the input. First of all, I'm just interested in delta in IL. So I will uncheck all of this and I will press here. Okay, now I can also make this white. Okay, now, okay, this is it. Now I will bring cursors and I will bring cursor here. From here, right click and go to Y max. Okay, then you will bring this here. Now right click and go to Y minimum. Now you see here, how much is this? 13.25. This is my inductor ripple. Okay, so 13.25 milli. Now I will come back to my here. Okay, Now 13.25. Now I will use this equation. So d is how much? 0.5 into 1 minus d is also 0.5 multiplied by Vs is how much? 5 divided by frequency 1k multiplied by inductor is 100 milli. So when I will calculate this on the calculator, so I will get 0 0.120 0.0125. So if I shift 3 points from here, it will be 12.5 milliampere, which is exactly the same here. Okay. Similarly for this one, now I will uncheck this one and I will bring V out. Again, I will press here. Now I will check. Okay. I can make it a bit smaller. Okay. Okay, now you see this is how much? 7. Okay, how because you will be confused with the. Um, okay, so this is how much? 7.415 milli. One cursor I put at the maximum, one cursor I put at the minimum. And then you will come back here. So how much I get? 7.4, which is also here same. So now I will use this formula. So D is how much? 0.5. 1 minus D is also 0.5. And Vs is 5 divided by 8 into inductor how much? 100 millihenry multiplied by C is 220 micro multiplied by 1000 square. So I get 7.10 millivolt. So this is almost same. Okay, so this is how you have to do all the tasks. Remember in your assessment here I used 100 milli, but in your assessment you have to use 300 millihenry. The steps will be the same. Okay, you have to put name your circuit here, then you will measure this duty cycle, then here measure the input and output voltage using the probes. The first one, when you had to carry out the interactive simulation, this one, then inductor current using the probe. So inductor current is how much? This one 23.5, and you have to use calculation also. The calculation is here, this one. Then here you have to use inductor current using equation, and here with the cursors, here for the output using the calculation, and here with the with the transient analysis. So you can take help from these slides and it will help you to do the simulation. Okay, for section 3 on Thursday there will be no class. Okay, I will extend the date for this simulation plus hardware experiment for all the sections till Thursday. Okay, you have to submit your simulation till Thursday, and remember you have to use 300 millihenry. Okay, so that's all.